Hey everyone, thanks for joining. We'll be getting started here momentarily. All right, we'll go ahead and get started here. Thank you all for joining our webinar today. This is going to be building your benchmarks, the discussion panel with Datadog, AWS, and HashiCorp. My name is Peter McCarron. I'm a senior product marketing manager on the Consul team here at HashiCorp. I'll be your moderator today going through all this. A couple of housekeeping items. This webinar is being recorded. We will be posting this to our website upon completion. Throughout the presentation, feel free to drop your questions into the chat. We have some questions that we seeded for our panelists here today, and then we'll be interjecting with a couple of your Q&A. So feel free to shoot them in there as we go along. And so at this time, I'm going to turn it over to our panelists to be able to introduce themselves. And I'm going to start with you, Amit. You're the first one on my screen here.
Excellent. Thank you. Hi, everyone. I'm Amit Al-Govrin, Global DevOps Partnership Lead at AWS Partner Network. I quarterback some of the most strategic partnerships in the DevOps segment here at Amazon, including our two good friends here at HashiCorp and Datadog. Nice to meet everyone.
Thanks, Amit. Next up, I got Mishra, who is no stranger to our webinars, but I'll let him introduce himself again.
Thanks, Peter. Hello, everyone. My name is Mishra. I'm the technical advisor to the CTO. I work in the office of the CTO on strategic initiatives, both internally with our partners like Amazon and Microsoft and Google. And yeah, I also lead our incubations team that focuses on new ideas inside the company.
Thanks, Mishra. Next up, we have Lolly for the Datadog team.
Hi, everyone. I'm Lolly Singh from the performance team at Datadog. I mostly work on strategic initiatives for better performance on important things, and then utilization.
Thanks, Lolly. And last but certainly not least, I got Paul Banks here. So Paul, want to introduce yourself?
Yeah, thanks, Peter. I'm Paul Banks. I'm the principal engineer on the Consul team here at HashiCorp.
Awesome. Thank you all. Thank you all for joining us today. Excited to get your perspectives on things. I'm going to start off with a nice, easy question. We mentioned that we're talking about benchmarks. So I'd love to hear what your definition of a benchmark is and kind of why you think they're important. So Paul, we'll go reverse order this time. So I'll start with you. A little bit of your experience about what benchmarks are and kind of why you think they're important for organizations to run.
Yeah, so benchmarking is kind of a term a little bit like testing. There's not just one way of doing a benchmark. You kind of have a spectrum, right, from kind of micro benchmarks that you maybe use as an engineer while you're kind of figuring out what's the right implementation for your sort algorithm, right up to like huge system benchmarks where you're trying to figure out how does Consul work on 10,000 nodes or something like that. So we're going to talk a bit about benchmarking in general, but we're going to be more at the kind of like integration, complicated systems end of benchmarking and thinking about how we run benchmarks within organizations and what's the value of doing that.
Awesome, thanks. Lolly, obviously Datadog team is very familiar with performance benchmarking. Curious to hear your thoughts on them and kind of why they're important to you or what you've seen from customers.
Well, I think first I want to say a benchmark is a controlled experiment, right? And in it, you measure something you care about in a safe environment. That's useful for anything from, can I handle this, or versus, can I afford to run this at the rate I want to do, right? And both end being important. Otherwise, the code you have written and tested isn't relevant to you, if it runs terribly.
Absolutely, I think that's a great point. Mishra, you just completed a benchmark, so you should be familiar with it. What's your take on benchmarks?
Yeah, I think both Lally and Paul covered most of kind of the basics of benchmarking and so on. I want to talk about why they might be relevant, and I think one of the reasons why benchmarks are relevant today is because we rely on a lot more software to get our job done today, versus maybe 10 years ago, right? And I think that that in itself kind of is a warning of you should have some reliable software running, and I think benchmarks help you to figure out how reliable the software is, how it behaves at certain scales, with certain input, and what type of output can you expect. And I think, as Lally pointed out, the idea is to do it in a contained way, so you have predictable inputs and kind of predictable outputs. So I think that to me is more interesting, of how do you measure the reliability, the predictability of some software that you're running, especially on the cloud.
Yeah, absolutely. I know we've covered a lot about the definitions of benchmarks, but I think similarly, it'd be good to get your perspective about why you think they're so important.
Sure. I don't want to have to repeat everyone, so I plus one, Lally, Paul, and but from the AWS perspective, if you want to kind of add a little nugget here, we believe in the shared responsibility model, where we provide that elasticity and scalability to meet the deployment needs, but it's really on the customer to make sure they select the right set of resources that fit those needs, and make sure you know how to perform that benchmark.
Absolutely. So the great answers all around as far as this. But Lolly, one of the things we didn't really touch on kind of who they help and what some of the other benefits of these are, as they apply to our actual customers. Do you maybe want to touch on that a little bit? I think we defined it pretty well, but it'd be good to just know what's the impact of doing this for you as a user.
Oh yeah. Actually, funny you should mention it. Today we released Agent 7.31. which has substantial improvements in performance and CPU and memory usage because of performance engineering efforts in this area. So that's one area for our customers to enjoy. For us internally, benchmarks help us reduce costs, frankly, reduce costs a lot, especially as you scale up. Costs scale up a lot and become far more sensitive to things you can performance engineer well.
Cool, thanks. And Paul, I know you've had some experience kind of designing these. I'd be curious to get your thoughts on what do you think some considerations that customers should take into account when they're designing these experiments? Because I think you did a pretty good job mentioning that it's pretty broad what you can be done. So what are some important things that you think we should cover?
Yeah, I think the really important point for me, Lally said it earlier, is that a benchmark is an experiment, right? So the closer you can get to doing real science, the better you can expect your results and the data you get from the experiment to be. So a key consideration is what is it actually that you're trying to measure or optimize, right? If you're kind of unclear and you feel like you should be doing performance and you just kind of throw a bunch of stuff up and see what happens, you might learn stuff, but it's probably not a benchmark. It's not going to help you optimize a specific goal necessarily. So understanding exactly what it is you're trying to achieve and optimize, and what does good look like? What do you expect to get out of it before you start is often an important thing to consider too. I think there are lots of others too, right? I think once you start doing an experiment, thinking about where your sources of error are. So you get a bad like things perform much worse than you expected, you then have to think about like, is that actually the system that's performing badly, or is it something about the way you're testing it? That is it like the measurement system, the metrics you're using being unreliable, and so on. So thinking about like what you're going to measure and how you're going to measure it are really like the two key points going into an experiment.
Thank you for that. And Mishra, we actually just completed a benchmark test that we did, and I'd love to hear kind of how you took some of those considerations that Paul just mentioned in designing that experiment, and like what were some of the things that went into how we designed that project that we wanted to get out of it. Would be great to get your thoughts on that.
Yeah, I think just to recap for folks that don't know, we finished, HashiCorp finished a pretty substantial benchmark for a Consul product in, I think we did it in February, but we published the results in April. And you can see there's a huge gap between us publishing and kind of collecting the results, because we were, processing the results, kind of figuring out how we want to tackle some of the challenges, some of the issues that we found in the benchmark. And how you can fix it and port it back into the product, and then we ended up releasing the results. So the benchmark was done to kind of mostly test the control plane side of our Consul product, which is a service mesh, service networking project. And the idea was to kind of really push the limits for the Consul servers to behave in a certain, maybe a weird way with a certain scale, and see how predictable that behavior is, and also kind of see the responsiveness of those of the control plane itself. So that was kind of the main focus for the experiment. The results were pretty great. Like what we found was that for 10,000 hosts running on AWS, we were able to kind of see when we would do a change in the control plane, we were able to see the change be delivered to those 10,000 hosts in about a second. And we updated about 172,000 plus containers, which were running applications under a second. So that was a pretty cool milestone for Consul, for HashiCorp. And some of the things that I think what we learned from doing that is that, what you think you set out to do and what your kind of targets are for a benchmark, like, the reality is quite different, like especially if you're running a benchmark in the cloud, there's a lot of things that is, that is unreliable. Something that Paul was talking about is like, for example, like we had issues with looking for specific events, and we were worried that whether we were even delivering those events. And then initially, we started, of course, we, like any other, software engineer, we started looking through logs and so on, and we don't, some portions we would see the logs, some portions we wouldn't. Then we were, kind of questioning whether our delivery system for logs was okay. So there was all these like parts to an experiment, and I would say a lot of that time is used up like figuring the kind of configuring the test bench, configuring the actual maybe your data gathering system or something like that. The actual experiment doesn't take too much of your time if you think about it. Like you just, and in some cases you're kind of restricted by cost, or, you're restricted by other resources. So you already know that you're not going to run that benchmark for a really long time. So a lot of your time is just consumed with the reality of running a benchmark, which is, the practicality with, setting up the test bench, the unreliability of the network, or, your software itself. And so I think, yeah, it's a very interesting kind of story as you begin to do this, and we learned a lot from it as well. Yeah.
Yeah, and if folks on here are interested, definitely check that out. We have it posted on our website. You can get into all the nitty gritty about how we conducted the experiment and what the results we saw are. And that experiment wouldn't have been possible without our friends over at AWS and also Datadog. But Amit, I'd be curious to hear, just like generally speaking, how AWS approaches benchmarks and kind of why what's the importance for your customers, and how do you try to enable them? Because it's a little bit different, right? People are using your infrastructure versus designing the actual experiment. So I think it'd be interesting for the folks on the call to get your thoughts as well.
Well, let's take that second part of the question. I think that's actually an interesting point. Benchmarking are really a way to assess your business KPIs in many respects if you're looking into a project or a product. So think about it this way: if you're looking to assess your unit economic costs associated with a new product release, in this scenario, you can go and compare your unit costs with similars in the space and make sure you know where you stack rank. If you're way outside of that standard deviation, you need to scrap the project. Might as well fail fast and move on, as opposed to needing to find out the hard way.
Yeah, for sure. You know, and as we're going through this, folks, I just want to remind people, feel free to drop additional questions into the chat. We'll be pinging them as we go. Just there's the Q&A box if you're curious, want to ask any of the experts on here any of the questions. Lolly, you know, we mentioned again some of those business metrics, but you know, as we shift more into the kind of performance engineering side, you know, how do we really gather this information, right? Like, what are some good best practices for gathering it, interpreting it, and, you know, what kind of overhead do you think folks experience when they're trying to do that?
I mean, I'm gonna say you use Datadog, right? Let's start off with that. But like, more generally, one of the best things about a benchmark is you can instrument it as much as you want, and you won't hurt anything, right? I can add as many additional counters and hash tables, distributions, whatever you like in there, and you know that you can measure exactly how much overhead you just added by running the benchmark again, just with the instrumentation in place, and just see how much you add, right? And then from there, you can go on and get more detail as you want. Now, the important thing is not to go too far or too little, which is when you're adding instrumentation, you have to think to yourself, when I'm done with this and get the data back, A, do I care? Or B, do I regret not adding more? Right? And that's a fine line to play. But the underlying criteria there is data actionable, right? Will this lead me to understand, should I spend more time on this function to make it more efficient? Or will I go like, oh, I don't care. And that goes back into engineering costs. But go ahead, sorry.
No, absolutely. What I found interesting there is I think, you know, you and Paul very much kind of approach it the same of like really designing those experiments and make sure that like, am I getting the data out of it that I want to? And I think that's a really important consideration for our audience members is that, you know, benchmarks are kind of flexible. You can do what you want, but you're going to get a lot of information, and how you interpret that is really going to adjust, you know, how impactful those results are. You know, Mishra, going back to kind of our benchmark, you know, I'd be curious how we defined our metrics, and, you know, what processes we wanted to implement as we were gathering them, that really made sure that we didn't get kind of lose the forest through the trees, like focusing too much on like one data point versus like what's the general theme that we were looking for. You know what I mean?
Yeah, absolutely. I mean, I think for Consul, for the benchmark, we were very ambitious initially. Like, I think we wanted to collect a lot of different things, improve a lot of different things. But, you know, of course, reality hit us like when we started like kind of designing some of this stuff, and we kind of, you know, narrowed it down to a specific thing. And the one thing that I mentioned earlier, which was just to test the control plane side of things. And so in a service mesh, for those people who don't know, there's two parts. There's a control plane, there's a data plane. Data planes are usually your proxy that just routes the packets from one place to the other. Control plane is the one that can, you know, essentially stores like a lot of configuration, can deliver service discovery data to these proxies and things like that. So control plane is the kind of the highly scalable portion, or like the thing that needs to be up, and it's supposed to be the reliable portion of the system. So that's one of the reasons why we wanted to focus on that one particular thing. And also, when we kind of looked out in the industry, there's a lot of benchmarks done on service meshes, but they were all focused on like the proxy, like, oh, how quickly is, you know, Envoy, for example, is able to route packets from one place to the other, or, you know, other proxies that are available. And you know, when it came to control plane, people said, yeah, you can, you know, in the benchmark, it would be like, or like in the documentation or whatever for these projects, I won't name them. It just said like, hey, like it works for like X amount of, you know, instances, and tens of instances and thousands of nodes. And, you know, and when you read that as an engineer, you're like, does it actually work for that amount of instances? Because it's not reliable. Like, it's not like actual data that you can show using graphs, or like actual defined thing that can analyze. There's nothing to that statement really. So that's one of the reasons what kind of drove us to kind of focus on the control plane side of things. And I think we've always been very confident when it comes to Consul. Like Consul's been around for quite a lot of years versus other service meshes or service networking projects out there. So we were quite confident that it was pretty efficient, but I think we wanted to kind of push the limits with that. The other things that I think Paul and I really, I'm sure like Paul has many things to say here as well, but Paul and I really spend a lot of time like narrowing things down to figuring out the exact, set of metrics that would help us measure this response time that I was talking about, which was, if there is a change in the cluster, for example, there's a new, service instance that comes in and gets registered and it comes online, gets registered. How quickly does that event propagate to all the different other instances that might be relying on that service or might be, upstream or, using that service as an upstream. So that portion was kind of the root of the benchmark. That was like the main measurement. And in order to do that, of course, we had to put measurements in on the actual instance side, the registration side, on the control plane, on the Consul servers, and kind of see that event come through. And then see it all the way down to the data plane and on Envoy, kind of see that event come through and see if it triggers changes and basically measure time there. So it's like, even in theory, it's not a difficult thing to do, but in practicality, it is difficult because the type of experiment, the way we designed it, it was quite convoluted. Like the way we designed it is like this pathological case where, there's one instance that pretty much is dictating a lot of different changes in a lot of different proxies. In this case, like 172,000 plus proxies across 10,000 hosts, right? So it's quite an extreme case if you think about it. Means hopefully in reality no one's doing that, but it's so funny. Like in previous, like whenever I've said the statement, I've always I've always come back on it because there are customers that will tell you that we have tried to do this and you'll be surprised that, and they've actually beat your benchmark or whatever your result was. And we've had this happen at HashiCorp for our Nomad scheduler. But yeah, means that's bound to happen. But yeah, those were kind of some of the things that we focused on. I'm sure Paul has something to add here.
I was going to say, Paul, Mishra set you up perfectly to be able to kind of expand on that. Love to get kind of your thoughts on, because you were part of the design portion of the experiment itself and really helping see the implementation. What did you have as far as like your considerations, what important information, and how did you kind of determine those things?
Yeah, I think when we decided that we wanted to try and kind of quantify the the control plane scalability rather than something else, I think the key is about like how efficiently and how quickly you can propagate changes throughout a large cluster, right? And so we could, and initially we discussed and tried this, we could, like Lally was saying, just add some instrumentation to all of our like client agents so that when they saw an update, they would just stick something in their logs or flip a counter or something in the metrics that we were viewing through Datadog. And then, we could just kind of do that. But we actually wanted to make it a bit more end-to-end and a bit more representative. So what we actually ended up doing was measuring we looked at the logs that Envoy outputs in debug mode and figured out what the log line was that represented the fact that this particular service has now been reconfigured actually in the proxy right there on the host. And then we made that our target, right? So we took the time measurement from when we made the change in the control plane, and then we streamed billions of logs, maybe Lally remembers how many, into Datadog from all these proxies, and then used Datadog's wonderful aggregation tools and all the rest of it to try and figure out what the window was, because obviously it wasn't all at the same time, right? Figure out what the window was for when the first and the last ones came in and what the tail looked like and so on. And that's kind of where we started our analysis. That's where the results come from.
TLDR, we use Datadog to do most of this.
Yeah, we told you, Lally, we're gonna mention the name Datadog at least 20 times. So keep the counter going for us. Make sure we know. I want to pivot a little bit here because we've been painting a very rosy picture of these experiments and all the great things that they do, but doesn't always go the way that we initially plan, right? Like, so I want to kind of hear from each of you, like, some common pitfalls or gotchas that, you all have seen or heard, or maybe we even experienced in some experiments. So Amit, on the infrastructure side, any considerations or gotchas you want customers to be mindful of as they're trying to design these things?
Sure, you said the operative word, plan. So what seems obvious to some of us isn't so obvious when you're in practice. Oftentimes it does get overlooked, the planning process. So think about a common mistake of not notifying your cloud provider to increase the rate limits ahead of time, or alerting to abnormal activity that may be flagged as, I don't know, Bitcoin mining, if you're not careful. So things of that nature. Also, it's worth ensuring that you have the right technical resources on standby. So if you're working with AWS, having your technical account manager on call to help with these. That's typically your ABCs of how to plan for these type of events.
Sure, Lolly, how about you? What have you seen, or what would you recommend?
Oh wow, sorry, I got started thinking about the question in the QA already, and I lost context for a second there.
No worries, we'll come back to it.
I got it. I paged it back in.
All right.
So on that note, like right now, I have this data set and I'm collecting it, and I have a Python script running. And one of the pitfalls is the Python script is now currently at a 0.5 terabyte of RAM, and it's going to take another 28 hours to process, and probably going to tell me that I have a bug in the script. So you got to be very careful with how this data can explode on you if you're not very, very careful.
Yeah, absolutely. I think size considerations is always a really important thing. And anytime you're running something that's going to take 28 hours, you want to make sure it compiles. Paul, how about you? Any best practices or gotchas that you've seen in the past that you want to share with the folks?
So, yeah, a couple, like one, just linked to what Lally just shared, like with our scale experiment we just did. One fun thing was we stood up 172,000 Envoy proxies and all hooked up to Datadog, right? And like we were looking for this one very specific measurement to get out of this. Who knows how many metrics an Envoy proxy emits? It's quite a few, right? It's like hundreds at least. And once you have 172,000, we got a very gentle message from our friends at Datadog saying, do you really need all of these data points being recorded? And it was a great lesson, right? We hadn't like thought about the sheer volume of what it was we were doing. And like Mishra hinted at it, like we had some debugging of log messages. We're like, log messages are going missing. I can't believe Datadog's dropping log messages. And Lally's looking worried. They weren't. Datadog was rock solid throughout this, but journald on the hosts was, what we hadn't realized is that Envoy was pumping out so many log messages, it was being rate limited at journald and just being dropped on the floor before it even got into the Datadog agent. So like, that's another thing that once you start analyzing things and you're like, wait, this doesn't seem right, you then have to really get super deep to try and debug the issues. And another place I've seen that in kind of smaller scale benchmarks is if you try and run like, what's the most throughput I can get from this web server on my laptop? You quickly realize that generating enough traffic on your laptop is probably the bigger bottleneck than what the server's doing in the first place. And so you can get very disappointing results and think this server's terrible, but actually it's the overhead of generating it, or it's limitations on how quickly your OS can open and close sockets and things like that dominate your results. So you have to be very careful to debug those issues and understand really where those bottlenecks are.
And that's why we tell people you should do it on AWS, right? I mean, like we shouldn't be doing it on our local laptops when we're testing out our servers for load testing. So, Mishra, I obviously I think you got lots of lessons that got kind of learned along the way, but general experience, any like key considerations or gotchas you want to make sure folks are mindful of?
Yeah, man, with the Consul experiment, like, I can be fully transparent. Like, it wasn't as straightforward. It took us months and months to get to a place where we wanted to. So I think one of the lessons that we learned was that, luckily we weren't, going for kind of the the goal on day one, right? Like the goal was to run 10,000 hosts with like a bunch of applications and all the logging, all the data, all of these things. We weren't trying to achieve that on day one, right? Like we started with 100 hosts, like 50 hosts, 100 hosts, tried out like whether like the test bench works, whether the metrics that we are sending are being delivered, and we are able to visualize them on Datadog, whether like AWS is behaving as we expected when we, scale up, scale down. All of these things have to be tested, right? Like, so you don't want to do it at a really large scale because there's so much more, variables that are introduced as soon as you increase this host count that, it makes debugging a nightmare, as Paul was mentioning. For example, that issue that he pointed out, right? Like first we were like, yeah, this is definitely our code that's not doing, behaving well. And, start from that layer, you all come all the way down to the system level thing that we didn't quite, could, kind of pinpoint for a really long time. So I think, yeah, it's really important to do that. Also, I think it's important to kind of create a mental map of like, what are the moving pieces in running an experiment. So even for the details, for example, like what's on the box that you're running the test on, what's running alongside your test, being able to have insights to that. Like it's really important to have system metrics that you might be using to kind of correlate events. You need to have as much insight as possible. So I think I would say don't go conservative on the number of inputs in terms of like your I guess number of outputs in terms of metrics. Like I think initially have as many outputs as possible in order for you to have more insight into your experiment, and then reduce it based on as you narrow down like things and you're figuring out, okay, the experiment is behaving as expected, that the test bench is behaving as expected. Then you can kind of close these extra unwanted metrics that are like data that you're probably sending out or kind of analyzing. So it kind of gives you good confidence to run that. And another thing that I think what we learned was what Lali pointed out, which was these running these experiments, especially at like really large scale, like 5,000 plus hosts. We don't have that. Didn't have that type of money to just like run them for hours and hours. We had like 3 or 4 shots at this, right? So we wanted to make it as reliable as possible when these things come online. Like at least the experiment should be set up, reliably. And then yes, things can happen when we actually run the test. It can go one way or the other, but at least the test should be running, right? So we had only a few number of shots. So we did everything in our power, like in terms of, for example, we changed the startup time for our scheduler nodes that schedules these things to be a random time between 0 to like 10 minutes initially or 15 minutes initially or something like that at a really large scale. So we don't actually, all of these nodes joining at the same time and like, overwhelming a scheduler. Like that would be a nightmare for us because we would have to clean the experiment up. We would waste a lot of money, and then we would run that again, kind of on a fresh run. So we did everything in our power to make our experiment run successful. And then the success in this means like you either get a favorable result or you don't, and that's okay. But at least you have a reliable test bench. So those were the kind of things we realized as we went through this journey, and we learned a lot in the process as well.
Yeah, no, I mean, again, I think we could expound for quite a bit, picking apart all the different pieces. Lali, so getting back to that question, we talked a lot about what Datadog was able to handle and how we almost, broke some things. But we'd love to get your perspectives on, how Datadog can really be used for performance testing and various other testing.
Oh yeah, definitely. And I mean, I use it all the time. It's great for that. So once you have some, well, let's do a little terminology. So like you're doing a benchmark against some sort of like value, like say, in the Consul case, it was how many hosts running simultaneously, right? And then from there, you're measuring like latency, right? To figure out if it's within threshold. So you have the two plots, and that's an XY coordinate on a nice plot to see how you're playing out, right? And you start plotting those out, and you start seeing a curve, or you start seeing a straight line, and you suddenly have a model for what you want. And then Datadog collects them, plots them, lets you analyze that. And then later on, as you have new releases and whatnot, or even tests, you can compare new plots, new data points against that model you had to see if something's changed and something gone worse, or someone did a great job and made things better. That's one example. But it's a big product. There's lots of stuff you can do. I mean,
Awesome. Yeah, absolutely. And we recommend going and downloading a free trial if you want to try and test your own experiment.
Yeah,
on it, right?
just to add to what Lali said, like I think just to be clear, like Datadog has no issues throughout our experiment. Like we didn't have to do anything. Like we were running default configuration on our agents. We didn't have to change any setting to make it performant for 10,000 hosts. No, like I think it was all done really well. Like it was like the public documentation that you can read. There was no special like internal meetings we had with Datadogs to performance tune for the experiment. It was all done as a customer, as we were viewed as a customer, even though we were working as kind of in partnership here. And yeah, that was really impressive to me. And didn't have to do. I think we did about 1.8 billion log events in total throughout the experiment. Datadog handled it pretty efficiently. We were able to parse through the events pretty efficiently. We didn't quite see any issues there. So yeah, it means big ups to the team there. Except for the fact when like we were sending unwanted data, like it didn't make sense. And they definitely warned us like, hey, we're watching your account. Like it looks like you're using all of this stuff that you probably don't need, and it's probably costing us money. So I think that's probably where like there was some filtering done, and that's pretty much it.
Awesome. Paul, your comment about Journal D kind of piqued some interest for some folks. And the question we got that came in is that, the surprise to hear that you could enable logging in your systems under test to the point that it would overload Journal D. If you're able to overload Journal D, you're most likely impacting the application on the host that happens to be doing all that logging. Would you just need to like rewrite the Datadog agent to keep it from getting overloaded, or like maybe talk a little bit about how we resolved that issue? Because I think there's just some questions about how we were able to keep the test running when we were overloading Journal D.
Yeah, so the host resources were really low. Like one of the key things was all the hosts that were running this had to be nowhere near their CPU limits, because otherwise you're not really testing a system in a kind of operational state, right? So it wasn't that. It's like it was a really specific thing that I definitely learned about, and honestly I've forgotten the exact details. But by default in the Linux distribution we were using, Journal D has a lines per second rate limit. And so it wasn't that we were sending it so much stuff it literally couldn't keep up. It was literally like it was doing 1,000 lines a second and then dropping it on the floor. And most of the time it was fine, so we didn't notice for ages. But it was very specifically when the proxies start up and they initially get this config, because they're in debug mode, they were just dumping like tens of thousands of lines of stuff all at once, and we were just losing bits of it. And just enough bits of it that it looked like half the proxies hadn't done the thing we'd thought they had done. And so it was like that level of debugging. It was definitely not that we were hammering everything so hard that it wasn't working at all. It was like a really specific setting that we had to go find and tweak.
Not hammering it so hard yet. we'll have to figure out what that actual load is.
Just to add to Paul's answer, like it was a very specific setting. I think it was like I just looked it up. It was the rate limit interval and the rate limit burst. So by default we were running the default system, like the Journal D setting, which is 1,000 messages with 30 seconds period. So you can clearly see like if you're running something in like let's say debug mode, an application's running in debug mode, doing a bunch of these events, you can easily overwhelm this if you could. I mean, especially in a benchmark of our size, like we were easily able to hit that limit. And this has nothing to do with the Datadog agent, just to be clear. Like the Journal D system job is very different from the Datadog agent. Datadog agent is just like essentially, grabbing what it's seeing from Journal D. So it's not really interfering in this process. So just to be clear, I think there was some mention of the Datadog agent there, but there was no rewrite that was done for the agent or anything like that.
Yeah, once we'd fixed that thing and just like, put all the nines in on the limit or whatever it was we did, like Datadog just slurped the whole lot up, no problem at all. It was literally just that limit was causing stuff to get dropped.
I think that goes back to your earlier point, Paul, about debugging and understanding like how deep you need to go to it and making sure you're ready to kind of adjust on the fly. I know we got some quiet audience members today, so I'd love to get kind of some main takeaways that you're hoping that the folks who are on here can walk away with. Amit, I'll start with you. We talked a lot about projects and performance. From your perspective, what are some of the main things that people should who sit on this or watch this recording, what should they walk away with?
I'll start with kind of a general observation around common mistakes, but this kind of goes into it. A lot of people confuse benchmarking and load testing, and oftentimes they're completely two different things, and you have to be careful because really one's a kind of a sandbox to play with, one's let's go and test that theory out, and you want to make sure you don't confuse them, because sometimes that can get you in trouble. I've seen that happen actually in previous companies I worked for. And more so on a key pointer I can offer, if you are using AWS, we have created a mechanism called Infrastructure Event Management, or IAM for short. Think about it as almost like a well-architected framework for how to plan for a compelling event where the abnormal amount of compute and resources are needed. So the IAM program is offered as part of your enterprise support plan if you subscribe to it, but you could also have that as an added fee for a business support plan. So that's one way of really planning ahead of time and making sure you're well set up for benchmarking and performance testing.
Yeah, and once again, just want to call out that we're extremely appreciative to the AWS folks. I mean, you all were a huge driver in us being able to run our benchmark, and it's really great to hear that if you're a customer who's thinking about running your own internal benchmarks, that there's a lot of programs in place. So make sure you check those out. Mishra, you've talked a lot about kind of our pieces, but what are the main takeaways you want to make sure that people walk away with today?
Means as a vendor, I guess, I can speak for HashiCorp. I think I really encourage folks to don't take the word on, what you read on the, marketing websites. Try it out, benchmark these projects, and see how it works for you. See the scale at which they're expected to run, and validate them. I think it's worth investing that time initially. I work for companies which are, of course, non-vendor companies, but I've used all these tools that are out there for various other things, like running applications or running databases or things like that. It's good to have that in your engineering culture, where you bring in a new project and you're able to kind of test it to its limits initially and then invest in it. Because once you start investing in it, it becomes part of your workflow, part of your technology stack. As you grow, right? Those promises sometimes don't hold true. As you grow, sometimes, because it's just software, right? You want to be able to kind of have some form of predictability there. So it actually helps to test the software out using benchmarks, or using I guess doing load testing, anything that you feel is appropriate for that project. And then actually it helps the vendors too. Let's say you do a benchmark on a project, and you find something out, it actually, you can feed it back to the vendor. They're able to fix it. Everyone's super open in the industry to kind of go and fix their products if there is a issue when it comes to scale, because scale matters a lot. Especially at HashiCorp, we care deeply about you don't know how intricate we are when it comes to building software. Even with this benchmark, we wanted to hit a certain number, that under a second number. And we wanted to perfect everything about the experiment. So we deeply care about these things. So I think it's good for the customers to go out there, test it out, and don't take the word what you read on the website. I think those are some of the things that I would want users to kind of think about when you think about benchmarks.
For sure. And for folks who don't want to just take our word for it on our benchmark, we've actually open sourced the experiment. So people can go ahead and try running it on their own if they want to see what the impact is, or even try to break 10,000 notes. Maybe do a little bit more. Lolly, how about you? What's the main takeaway you're hoping that people can walk away with today?
Well, first I'll start off with saying that by the amount of AWS and Consul we run, Datadog is a continuous benchmark of both systems. A lot. But the main takeaways, I think, are a benchmark gives you a real flashlight into your system and how it behaves in real life, right? It gives you an intuitive feel for how it runs. And that gives you an understanding and a confidence that's very hard to get otherwise. And it's often, like, I know in this case, it was expensive because Consul went way up, but benchmarking is often really cheap. I mean, oftentimes time on the shell is a great benchmark for what you need, right? It doesn't take much and it gives you great bang for your effort buck.
Yeah, absolutely. I think that's the thing that always scares people, right? They're like, oh my God, what's the price tag on that? And, you know, when you look at the return and you look at the outcomes and what you can do with the data, I think it's really critical that you do that. Paul, how about you? Main takeaways. I know you've done this experiment. You've been a part of some other experiments with some of our customers. Curious to hear your main takeaways that you want to make sure people walk away with today.
Yeah, as an engineer, I have a healthy dose of skepticism for any benchmark result that ever comes across my lap. And like, I think my takeaway would be to like appreciate what a benchmark is telling you, but also what it's not telling you, right? Like, there are almost zero benchmarks I've ever come across that reliably allow you to compare two different experiments done at different times on different systems, right? So don't use benchmarks as like a point-for-point comparison between two different products when they were run by different vendors and they were, you know, even if you go into the detail of their methodology and the hardware they used and it looks about right, like, that's not where I see the value in benchmarking. Benchmarking is most valuable when you do it on your own stuff, right? You learn the most out of a benchmark when it looks exactly like your production workload, and, or, you know, like, you have the same shape, you're doing like the same size requests, you're having the same mixture and distribution of traffic that you might have in production or something close to it. And no vendor is ever going to like model that closely enough to be able to give you like the same quality of information that you get from running that benchmark yourself on your exact systems and your exact hardware setup and your exact Linux log configuration, whatever it is, right? Like, so I think for me that's the takeaway, right? Like, get comfortable running your own benchmarks, whether that's tiny ones like Lally was saying on your shell, whether that's integrating larger ones into your development process, and you'll learn a lot that way. You'll optimize a bunch of costs that way, and you'll hopefully get more of an appreciation when you do see vendors doing benchmarks of what they're trying to tell you and what they're not actually telling you, which is, look at us, this is better than this other thing, because they're not useful for that. They're useful for showing you a particular property of a system.
I think that's a really important takeaway there, is that, you know, we put out this test because we're like, this is interesting, and you know, we ran it at this scale and we hope that you find it interesting, but it's not like a one-to-one comparison on anything else. So that is absolutely true. Anyways, panelists, I want to thank you all so much. This has been a super fascinating conversation for me. I get to just grill a number of experts on some really interesting topics and things that, frankly, I don't have a lot of experience doing myself. So it is always super fascinating. I want to thank everybody who joined us today, and especially want to thank our speakers. As a reminder for folks, this has been recorded. We will be posting it to our website, usually within about like 3 to 5 business days. And with that, I can give everybody a little bit of time back in their day. I want to thank you all for joining us today. And yeah, have a good day.
Thank you so much.
Hey, everyone.